What's going on, everyone? You're here with Jono for another quick math lesson. Today we're going to look at how to multiply surds together following a few rules. So this lesson does actually have quite a bit of information, so taking the notes for this one will hopefully be really helpful for you if you're going back to study. So the first rule that we've got is that square roots and powers cancel each other out. What I mean by that is if I've got the square root of 4 all squared, this is just equal to 4, the number underneath. So another way that you could think about this is that if I had the square root of 4 and I did that first, that would be equal to 2. So I would have 2 squared, which means 2 multiplied by itself, times 2, which is also equal to 4. So either way, you can see that this is the proof that's always going to work. So the same thing works even if we don't have a square number that we can easily see. The square root of 5 all squared is just equal to 5. So the general rule that we have is that any number, anything, any algebraic term, if it's square rooted and squared, the final answer is just what's under the square root sign to start off. The second rule that we have is that we can combine our multiplications even if we've got different surds under 2 different square roots. So for example here, if I've got the square root of 3 multiplied by the square root of 3, just from that last example, we know that this is equal to 3. Square root of 3 squared is equal to what's under the square root. But then I've also got the square root of 9 I know is equal to 3 as well. So these two are equivalent. So one way that I could write this 9 underneath that square root that it has is I could break it down into its factors immediately. So this is the same as the square root of 3 times 3 under that root sign. If you throw that into a calculator, you'll see that that's equal to 3 as well. And this even works for numbers that are not the same. So that combination of 2 square root signs means that we can put everything under one term, which is making it more simple. So for this root 2 multiplied by root 5, all I have to do is throw that root sign and multiply these two integers together, which is just equal to root 10. Finally, with one more example, if I had the square root of 4 multiplied by 7, that would be equal to the square root of 28. The other way I could do it is change this root 4 into 2 to start off, then multiply it by root 7, which we just write very similar to how we do with algebraic terms as 2 root 7. The general rule, the one that you do definitely have to know, and I would recommend writing down, is that the square root of anything multiplied by the square root of anything combine. So square root of A multiplied by the square root of B is the same thing as the square root of AB. The reason that this is really important is because we can break down a surd using this exact same skill. We just said this is true, so that means that the square root of AB is the same as the square root of A multiplied by the square root of B. So if you can find factors within your surd term that you've been given, you might be able to break this into more manageable chunks. For example, the square root of 14 is the same as the square root of 2 multiplied by the square root of 7. That's a fine breakdown. If your teacher wants you to write it under one surd, that's fine. But if they ask you to expand it out, this is also correct. The square root of 26 is equal to the square root of 2 multiplied by the square root of 13. And we can't break down either of those other surds because everything in here is prime. So that's as much breaking down as we can do. Finally, if we have the square root of 20, we could break that down in a couple of different ways. This first time I'm going to break it down as root 10 multiplied by root 2. But I can actually break down that root 10 even further, which would be root 5 multiplied by root 2 multiplied by root 2. And then we can see here at this end bit, root 2 multiplied by root 2 is just 2. So my final answer would be 2 root 5. There's actually another way you can do this, which takes out a little bit of the work that we did in that example. Instead of choosing 10 and 2, if I choose a factor that is a perfect square immediately, I can get rid of that middle step. So instead of 10 and 2, this time I'm going to choose root 4 multiplied by root 5. Root 4 is just 2, so immediately that becomes 2 times root 5, which is 2 root 5. The big tip that I've got for these ones is please use your calculator to check your answer. In tests, there are 2 3-mark questions that just say, simplify this surd. Take it from one and break it down into a few others. If you use your calculator, the answer is going to be the exact same, because what you're saying is that this thing broken down is the same thing. So if I typed root 42 into my calculator, the answer I get is 6.48 and then a whole bunch of decimals. If I think that the breakdown for this is root 7 times root 6, because 7 and 6 are factors, if I just type root 7 times root 6 into my calculator, bang, I get the exact same number, meaning that I know I've done this correctly. Just a final point on writing these down when we've got a whole number. We just treat the surd like we do a regular algebraic term. So a whole number multiplied by a surd will look like 4 times the square root of something. Instead of writing that times, it's just the convention to write it as 4 root 5, and that's full marks. I hope you found this helpful, and I'll see you guys later.